This is lesson 2 for year 7 decimals. Today we'll be looking at how to round decimals. The intentions today will be to be able to identify the critical digit for any rounding operation and to round decimals to a given number of decimal places. You'll know you've been able to do this when you can determine the critical digit and also then round the decimal to the given number of places. Key ideas to know here: that rounding involves approximating a decimal number to fewer decimal places. The actual rounding process is very similar, if not the same, to a rounding of a normal number. We first cut the number after the required decimal places. So in the example that we have here, we're going to be rounding to 2 decimal places. So we can see our cut is actually made after the second decimal place here. You then look at the next number to the right, which we call our critical digit, and that tells us whether we should round up or down. We use the same rounding methodology, so if the number of our critical digit is 0 to 4, we will round down, and if our critical digit is 5 or more, we will round up. If we need to round down, everything from our critical digit to the right just becomes zeros and therefore can actually be excluded from the decimal. If we are rounding up, the number to the left of our critical digit or to the left of the cut gets rounded up by 1. The questions that you need to do are shown on the screen here. And again, we will have a look at how to actually do each of these questions. And again, as with previous videos, the questions are taken directly from the text, however numbers and some samples have been changed slightly. So question 2 asks us to round off to 1 decimal place. So the way we need to work these out is to write out our number, so 15.83. We're going to 1 decimal place, so after the first decimal we need to show our cut. This becomes our critical digit. Our critical digit is 3, so that indicates that we're going to round down. I'm going to show this with an arrow. So it is going to be approximately, and again I have to use the approximate sign, 15.8. I don't need to show the 0, okay, because zeros after are not required. For B, it is 0.79, showing our cut. Our critical digit here is 9, so that means we're going to be rounding up. So when we round up, the 7 in the tenths column rounds up by 1, so we get that to be approximately equal to 0.8. In our third example, 0.97, show our cut. It is a 7, so we're rounding up. So in this case, it's going to be approximately equal to, now the 9 needs to go up by 1, so that in fact has to then carry over into the whole number. So we actually end up with 1.0. Question 3, again, we're rounding off to 2 decimal places now. So the process is identical, we're just going to 2 decimal places. So we're going to say 3.7823. After 2 decimal places is our cut. Our critical number here is a 2, so we're rounding down. So we get that being equal to approximately 3.78. The second one, 5.9156. After 2 decimal places, we show our cut. Our critical digit is a 5. Now remember, the 5 actually means that we round up. Okay, so that becomes approximately equal to 5.92. And our third example, 123.456. After 2 decimal places, we show our cut. Again, our 6 here, means we round up. So it's approximately equal to 123.46. Question 4. Again, we are rounding to the specified number of decimal places. So in this case, the bracket here is telling us how many decimal places we need to round to. So in this example, we're rounding to 1 decimal place. So we have 15.913. we want to round to 1 decimal place, so we show our cut after the first decimal. Our critical digit is 1, which means we round down, so that's approximately equal to 15.9. Second example, 235.62. Now, the roundings to 0 decimal places. So that's a little bit interesting. We are cutting right here. All right, basically where the decimal place, we don't want any decimal places anymore. So our critical digit becomes the first one here, which is a 6, which means we round up, which means this is going to be approximately 236. The 5 gets rounded up by 1. And in our third example, 231.86, again, we want to round to 1 decimal place. So our cut comes in here after the first decimal. Our critical digit is a 6, which means a rounding up, which means it's approximately equal to 231.9. Don't forget to always show your cut and show your critical digit, just like I've done here. Don't forget to indicate whether you're rounding up or down, and don't forget to indicate, or to use, I should say, the approximate equal symbol, not the normal equal symbol. What you see here is what I would expect to see in a test question. Question 5, rounding each of the following to the specified number of decimal places. So again, this is no different to the last question. We just happen to be using a lot longer decimal number. So it is again 29.999731. The brackets is indicating to the third decimal place, so we are going to cut here. The 7 is our critical digit, so that means we would be rounding up. Now, where this one is interesting is if we round up, this 9 here becomes a whole number going up again, which will trigger this one to go up again, which will trigger this one to go up again. So we end up rounding all the way up. So a little bit interesting, this one. So we end up with the 9 having to flow up to that one, which then triggers that one to flow up, which actually triggers that one to flow up, and even that one flows up one more. So in actual fact, this one ends up being approximately 30.000. Now this is very important. I can't exclude the 3 zeros after the decimal point because it specifically asks us to round to 3 decimal places. So I need to have 3 decimal places here. So even though normally speaking we don't need all these zeros after the decimal place, because the question specifically says to the specified number of decimal places, we actually have to show them in our answer. We can't exclude them now. Question 6, round each of the following to the nearest whole number. So again, this is the same as saying round to 0 decimal places. So we don't want anything after the decimal point. Actually, we don't even want a decimal point when we finish these questions. So we have 10.458. So to 0 decimal places means our cut's happening here at the decimal place. Our critical digit in this case is 4, which means we round down. So it is approximately equal to 10. No decimal places are shown here. 123.72. Show our cut. Here's our critical digit. All right, it means we're rounding up, so it's going to be approximately equal to 124. Again, there are no decimal places shown. 19.92. Here's our cut. Here's our critical digit, so 9, so we're rounding up. So again, this is one of those ones where when we round up, this 9 actually has to trigger a carryover, so this becomes approximately equal to 20. Question 7 is asking us to round to the following to the nearest whole number. Now these are dollars, okay? To start with, we can just treat them like a normal number, but don't forget to include the dollars sign later on. The second thing this tells us is we will still need to keep 2 decimal places regardless of whether we have zeros or not, because we're showing dollars, okay? So here we have 13.86. We want to round to the nearest whole number, so our cut is actually here at the decimal place. 0 decimal place is being shown. Critical number is 8, which means we round up. So this becomes $14. And this is the special part here. We need the dollar symbol, and we're going to keep the 2 decimal zeros at the end, even though technically speaking we don't. And in a normal question, if it said the nearest whole number, we would actually exclude them. But because we're showing money here, we're going to keep the zeros after the decimal place. For the second question, $1.39. Here's our cut. Here's our critical digit. 3 means we round down, so this becomes $1 and 0, 0. Whoops, almost forgot the dot. And again, one thing I did forget in both questions was to show the approximate equal sign. Make sure we do that. And then the last one, 955. Here's our cut. Here's our critical digit. A 5 means we round up, so it's approximately equal to, again, this is going to round up to 9, which triggers it to round up to 10. So it's going to be approximately $10. Again, I'm keeping those 2 zeros there, even though strictly speaking, I don't need them in a normal question. But again, one more time, remembering we are dealing with money, so we are going to show the 2 zeros after the decimal point. Question 8. Some people like to round off their shopping as they do it to the nearest dollar. It's certainly something I like to do. They can keep an approximate running total of their cost. We're going to use this technique to estimate the cost of the following. So what this means is it's very easy for most people to keep track of whole monetary amounts, so $1, $5, things like that. So by being able to round it off to the nearest whole dollar, it makes it easy for people to keep track of that. And what we're interested to see is whether or not that's a good process. So we have 5 different numerical values here, dollar values, and we need to first of all round each of them off. I'm going to do the first couple in the full steps, and I would expect you to do that in a test situation or in your workbooks, but I won't do all of them with every single step. So the first one, we have $3.55. Okay, so we're rounding this off to the nearest dollar. That's what it's asking for. So that's the cut at the decimal point. 5 means we round up. So this is approximately equal to $4. Okay. The second one is 85 cents, so 0.85. Here's our cut. Here's our critical digit. It's rounding up as well. So that means that's approximately equal to $1. Okay, so as I said, I'll just do the first couple like that. Please make sure you do all of them. You need to practice the rounding process. But essentially, the first one would round to be $4. This would round to be $1. This would round to be $5. This would round to be $9. And the last one would round down to be $12. So rounding up to be 4, rounding up to be $1, rounding up to be 5, rounding up to be 9, and rounding down to be 12. Then it wants to know how close his estimate was. So what we need here is to add these up. So we have 4, 1, 5, 9, and 12. So 4 and 1 is 5, and 5 is 10, 19, 21, and 2 and 1 is 3. So we're saying his rounded estimate is $31. In part B, it says that his actual amount, if we added the original amounts up, was $30.30. How close was he? Well, if his number was $30.30 and we had $31, how close was he? Well, we can see that he was only 70 cents difference. So Joe's estimate was 70 cents higher. And question 9. We have 2 runners who get race times. Jenny gets 12.83 and Jane gets 13.17 seconds. Now, question part A says, if the race clock can only show times rounded to 1/10 of a second, what would be their time difference? So the first thing we need to do is round both of these times to a single tenth. So that means we're rounding to the first decimal place, which of course means we're rounding to 1 decimal place. So let's round off Jenny. Hers was 12.83. Here's our cut, our critical number. So that's going to be, and that's rounding down. So that's going to be approximately 12.8. And for Jan, hers was 13.17. Our cut, our critical number, hers is rounding up. So she'll be approximately 13.2. But it actually asks us what the difference between the times is. So difference, of course, means subtraction. And we may not be fully aware how to do a subtraction with decimals, but the easiest way to think about it is just treat them as normal numbers and ignore the decimal place for the moment and add it back in later. And just like any subtraction, it's really critical that we keep everything lined up. So we're obviously going to take the smaller number away from the bigger number. So we're going to have 13.2, but we'll just ignore the decimal point for a minute, and 12.8, again ignoring it. If we do this just like any other subtraction, so we can't take 8 from 2, so we have to borrow from here and put that one there. And so that gives us 4. 2 from 2, of course, is nothing. 1 from 1 is nothing. And we get, if it was normal subtraction, a 4. But we then want to put the decimal place back in. So what we have here is 004. And originally we started with a single decimal place. So we want to have, again, a single decimal place here. So our answer actually becomes 0.4. We don't need the second 0 at the front, but remember we always need at least something on the left-hand side of a decimal place. So we do have a 0 and we have 0.4. So the answer here would be that, that Jan's time is 0.4 of a second slower than Jenny's time, or you could say it the other way around, that Jenny's time was 0.4 of a second faster than Jan's time. Now part B says, if the race timers could record to 3 decimal places, what would be the fastest time at which Jenny could have run? Now this is another one that we need to think about for a moment. So Jenny had a time of 12.83 originally. But what we're trying to work out is if we could go to 1 more decimal place originally, what would be the biggest number we could put into this space here to still keep 12.83 as our answer if we rounded to 2 decimal places. So if we think about it, if we had a cut here and we're trying to work out what number would go into this space here to still allow us to keep a 3 there, well, we know we can't round up, because we round up we would have gotten to, this will turn into a 4. So the biggest number we can have here will be a 4. Because if we have a 4 here and we do this rounding as it shows at the moment, we will stay at 12.83. If we went a 5 or greater into this spot, we would end up rounding up, so this 3 would become a 4, so it wouldn't be the time that we've been shown. So it's a little bit of a tricky thing to get your head around. What is the biggest number we can put into the critical number position so that we don't change, in this case, the 3 that we've got after our cut? So the biggest number we could have would be 4. So her fastest time would be 12.834, and that would allow the board to still show 12.83 if we do our rounding.